In this illustration, we'll analyze the capillary action in a sealed glass tube. We are given that a capillary tube sealed at one end has an internal radius r, and we are required to find the length of the tube so that on dipping its open end vertically in a liquid of density ρ and surface tension T, liquid rises in the tube up to a height h, and the atmospheric pressure we can take as P0 and angle of contact is 0 degree. So if we draw the situation corresponding to the given case in the problem, say we are having a liquid in which the tube is placed in it in inverted fashion. So in this situation, when the tube is inverted, we are given that the liquid will rise in the tube up to a height h. And atmospheric pressure we can consider as P0. So here we can first calculate the pressure of air inside the tube. If this air we can calculate if liquid rises to height h in tube, the air pressure in tube is given as, we can calculate pressure on the atmospheric level is P0, and up to a height h just below the meniscus the pressure will be minus h rho g, and above the meniscus it will be an excess pressure which is 2T by R. So this is the pressure of air in the tube. And if say the length of this tube which is inverted on the liquid is taken as L, then we can write using gas law for the air in tube, we can write P1 V1 is equals to P2 V2 as we are considering the temperature of air to be constant, and initial pressure of air was P atmospheric and its volume can be taken as its length, and cross-sectional area can also be taken which will cancel out, and this should be equal to the final pressure which is P air, can be written as P0 minus h rho g plus 2T by R. And now the length of air is L minus h, so volume is L minus h times A. Here A gets cancelled out, and if we simplify this relation, this gives us P0 L is equals to P0 L minus h L rho g plus 2T L by R minus P0 h plus h square rho g minus 2T h by R. Here P0 L also gets cancelled out, and on simplifying this relation we get the length of this capillary tube which is given as P0 h R minus h square R rho g plus 2T h R divided by this 2T minus h R rho g. That is the result of this problem, the length of the sealed capillary.